I'm here to talk about security today. I'm going to talk about a couple of different things when it comes to client-side security, with the main focus being on how the challenges have changed over the last few years, how we can cope with those challenges, and then how we can go about sort of testing and making sure we're actually dealing with those challenges. So yeah, I am Joe Pettersson. Follow me on Twitter or GitHub, please. I'm an attention seeker. I work at a company called McKinsey & Company, and usually like the company that people work for is or is not relevant in these talks, but I think in this case it is, in that McKinsey & Company has a lot of very large clients, and a lot of those clients work in high security environments. They're defense contractors, they're oil and gas companies, they're big financial institutions. So we do a lot of this stuff. We do a lot of penetration testing, a lot of security auditing, and just generally we place a lot of focus on the security quality of the code we produce. So that sort of raises the question, why do we want to talk about it? And for me, I think the simple fact is that as people who work in the client, we don't think about security enough. I mean, the classic idea of, pardon me, I'm a bit fast. The classic idea of front-end development, until very, very recently, was maybe you did form validations with jQuery, right? I mean, it didn't get a lot of respect when we did that, but now we're doing much more complex things. The way we think about security has to change. The more business logic we place in the client, the more security we have to validate in order to achieve success with whatever project we're putting on. And part of that, right at the heart of this problem, lies what's called the client environment, right? And that fundamental problem is that we don't control that environment. And as it says up there, any environment you don't control is a fundamentally untrustworthy one. We ship some HTML, some CSS, some JavaScript, some whatever it is, and we ship it off to a remote location, and they run it in some way that we can't very easily verify. And that essentially means that there has to be trust boundaries between the two. And the way that that's classically been worked with is the idea of strong decoupling, of decoupling the your front-end application, be it a complex Angular app or anything else, from your back-end data services. This isn't a new idea, but essentially it leads to something like this, right? There's this black box, or white box in this particular context, unfortunately, that takes some input and gives some output. The classic idea of this, as I talked about, is double validation, right? I'm sure you've all done this before. You have a form on the client that a user introduces some information to. You do some validations, maybe an email address, password length, whatever it is. And you do that validation again on the server. It's not very dry, but we've all done it, based simply on the fact that you cannot trust what comes from the client. Again, another classic implementation, another classic case of this is a client-side app not actually trusting the output from any data services it owns, even if you own both sets of code. A great example of why this is a problem is simply the fact that that is the main leverage point for a lot of exploits, for instance, reflected or stored XSS. The classic example being somebody entering alert foo into a comment field on a blog, saving it, and then when you get that back, if you're intrinsically trusting your data, that means that you could pop that script and it could execute, and you've got an XSS attack. That's a stored XSS attack in this context. But one of the things that we need to understand is that while that is a very binary model, you have a client and you have a server, and there are relationships between the two, and there's an implicit or explicit trust boundary between the two, that isn't necessarily all we need for this cohesive trust model to exist. And this isn't a new idea either. This is something that's been happening for years when it comes to secure network architectures. You don't just authenticate in one place around the outside of your network, because if someone penetrates that, your entire network is owned. So the idea is that with these new apps, with sort of thick clients and these very complex business logic heavy applications we're building, these ideas need to change, and we can get a lot of insight from all of these lessons that have already been learned. In this particular context, we can see the old model on the left-hand side, which is you have some sort of data service, and within it you have some sort of client, and there's a binary relationship between the two. Whereas what we need to start moving towards is actually componentizing our trust boundaries between our models, our views, our controllers, if your application happens to be built that way, or just between different services if you're using an application and another. Another sort of canonical example of this is a view not implicitly trusting the output from a model. For the exact reason you can probably imagine, that if in some way that the code within your model is exploited, that also means that your view is exploited. And in this context, your view is interacting probably with the DOM, and the DOM is a huge attack surface for XSS exploits. So therefore, if you can have a trust boundary between the two, it means that your application has these modular, cohesive trust boundaries, much in the way that your code is modular in its architecture, which is great, because it means that, again, if your model's owned, that your view isn't necessarily, which can make attacks against your application much more difficult. So these ideas are getting more complex. I mean, architectures and applications are getting more complex, and technology is also getting more complex. It's not just this long list of things anymore: content spoofing, XSS, cache poisoning, path traversal. It's also this last one, because there's a new set of technologies available that we're working with, hardware APIs, WebGL, all these kinds of things that interact with data and the security ecosystem of a particular client in different ways. And again, somebody else said this earlier, I'll preface this again, this is a constantly changing landscape. So some of the things, as again they said earlier, are probably not even true as I'm saying this. But hopefully we can go through. So what I'm going to do actually is I'm going to go through a couple of quick examples about where these particular issues come into place in a way that maybe we haven't had to think about before when we're doing front-end client-side security. For instance, web messaging and the cross-domain API. This is if you've ever done this, it's fantastic. It's a great bit of technology. It has its problems, but the fundamental idea is a good one in that you can communicate across multiple tabs. But one of the issues that people have when they started doing this is that there's a post message method that essentially allows you to send a message, as you probably imagine. But rather than actually setting an explicit string for the expected origin for the second argument, they set WildStar. So essentially means that you can subscribe to that message from any other tab. So essentially means anyone can communicate and spy on the information that you're sending out. And there's lots of these examples, but this is another one I've seen in lots of places, is validating FQDNs. This is just a little sort of pro tip that I've come across lots of times. I've seen this a dozen times before, of people actually, okay, I need to validate the origin of a request or something else, so I'm just going to do an index of on the string. And that must work, right? But as you can see below, the problem is that that's a pretty trivial thing to do with DNS in order to get around. I want storing data in the client. This is a really, really interesting set of problems because we've got all these new APIs, got local storage, IndexedDB, Web SQL, and all of these involve challenges that typically we've never had to deal with before. Storage has always been in the DOM, classically, right? And it's horrible and it's unwieldy. But when you store data in the client, there are all kinds of other challenges. Again, you've got pump and dump problems. There's no... with cookies, you can set domains, right? And you can set paths within domains. So only allow it, like in Twitter, so you could be /Joe8bit can access a cookie. Whereas that's not actually true with some of the DOM storage APIs. So for instance, if I can introduce a script onto my page, someone visits my page, I can grab all their information from session storage, local storage, IndexedDB, yada, 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 without actually having to get around any of the security issues that there are with cookies. And again, there are lots of things like this. And again, SQL injection in Web SQL is also a very interesting one. As front-end developers, we've never really had to think about SQL injection in any other sense than it's somebody else's problem. So again, there are lots of issues here. Again, web workers, it's pretty trivial. If you've ever written web workers, you've probably DOS'd yourself at one point when you're experimenting with them. Doing that in anger is a very easy thing to do. Just run a sort of a recursive Fibonacci sequencer that they were talking about earlier with the functional programming, and you can just brick the entire tab, or the entire process if we're using Chrome. It's very easy to do. Iframes, sandboxing iframes. Iframes are a pain for security for many reasons. Breaking out into parent contexts, into different page fragments, as you're probably all aware, is incredibly easy. However, there is a new thing called sandbox in HTML5, which essentially allows you to block a number of the exploit paths that are typically used from iframes into the parent page. And I'd encourage you to just take a look at that. It's really awesome, super easy to implement, and you get a great level of security if you're forced, maybe at gunpoint, to use iframes. The other one is offline applications. So they were talking about this earlier. This is really interesting that I actually worked with a group that developed a man-in-the-middle attack against manifest files. What it essentially means is that if I control a network that you're running on, I can inject a manifest file into your request, which forces your browser to cache any file I like. So essentially, it means that I can poison jQuery, I can poison the XHR methods in jQuery, so that it automatically posts data to your intended endpoint and to my endpoint, and you can imagine why that's a security problem. This is less of an issue with service workers that I was talking about earlier, because they have programmatic access, right, and so you can validate conditions. But it's still an issue to think about when you're doing these offline applications, in particular, they talked about the developing world. Unfortunately, in a number of developing world countries, there's quite repressive regimes when it comes to content. If I'm if I'm a country that wants to monitor everything someone's doing, why don't I just inject manifest files into every single web page they view if it's not over HTTP? Essentially means I can completely do whatever I like with the execution context on that page. WebGL, this is a favorite of mine. I've done a lot of work on this in the past. Essentially, WebGL is a massive, massive security change when it comes to front-end code. Because classically, the way it works, as I'm sure you probably know, the browser lives in user land on an operating system. Essentially, there are all kinds of controls and sandboxes that it lives within that prevent it from doing things that are going to otherwise affect the surrounding operating system and the hardware beneath it. With WebGL, that's not necessarily true anymore, because you're running code in kernel mode, right down at the lowest layer in the system on the graphics card, actually translating things into machine instructions that are being directly addressed on hardware. Now, that's a problem, as you can probably imagine, because you're no longer just relying on the browser and maybe the operating system to maintain a secure environment. You suddenly have to rely on the quality of graphics drivers that are implemented by the graphics card vendors. And there's a great Steam does a survey, a long-running survey about hardware and everything else. I should actually quote this on here next time I do this. Essentially says that in terms of browsers, 95% of their users are on the most recent version of any particular browser. The same thing with operating systems, similar numbers, about sort of 80–90% are on the most recently patched OS version, same with plugins. But when it comes to graphics cards, even the people who have the most to gain from having the most recent set of graphics card drivers, only 45% of people have the most recent set of graphics drivers. And so that means that if there have been like shader exploits in the graphics driver software and it's been patched in a recent version, the odds are users aren't going to have them. And so this Angle project from Chromium, they've done some really interesting things about validating machine instructions that are actually sent to graphics cards and the way they work. And it's really great. It's actually, if you're interested in this kind of stuff, it's a fantastic project to look at. The code's kind of complex, but if you can wrap your head around some C++, you'll generally be okay. So this is just a sort of a quick diagram of what one of those WebGL attacks looks like. You can see normally we live in this nice, safe yellow space in user mode, where the browser wraps us in a nice comfy blanket, where we're in 2 or 3 versions of sandboxes, whereas running WebGL code means we're much lower down in the system. And so it means that you can effectively do anything. You can directly address CPUs, you can directly address RAM. Now there are some protections in place to isolate a graphics card from exploit from the central processing unit of a particular operating system, but essentially you're going to be reactive to this stuff, and it means that there's a whole new security context that we have to look out for. So I've got 7 minutes left. I'm going to actually talk about testing, as I said. So that's sort of like why we should do it, and then a little bit about how we should do it. So I'm going to talk about verifying how we've done it, essentially. Then you're going to talk about auditing, and we could talk about this for hours. Auditing is something that you may or may not have done already. If you have done it already, it can feel a very medical process, and it's something that most people don't enjoy doing. But there are some core concepts that you should bear in mind. This doesn't just apply to JavaScript, but for code generally. Is essentially there are 5 things that you want to learn from auditing. What are your integration points? Where do those trust boundaries lie that we talked about before? What's the breadth and depth of your attack surface? Are you using some of these APIs that are going to change the way you normally think about front-end security? Where are your trust boundaries? As I said, look at a more strategic level to see where does the trust lie in my app and where are my data interactions happening? What are the fundamental security implications of technology and choices? As I said, if you're using a hardware API, for instance, on a modern device, there are things you can do, like you can do for vibrate with a hardware API from the web. If I constantly trigger that hardware API, it's going to kill someone's battery, right? That's implicit about the technology, but it's coming from the web and we've never had to think about before. And then auditing is essentially just understanding risk. It's about understanding where your risk points are in your application so you can work around them and you can mitigate them as well as you can. What's great about this is that it's asynchronous. I love the GitHub flow, fork, pull request, merge. I think it's fantastic. And auditing fits really nicely into this. And the auditing is part of the merge process. It's the merger has to take ownership of code quality that goes into master, for instance. They should also have to take, and test coverage or anything else your particular organization has. They can also take ownership of security consequences in the same way that the person writing the code does. This is awesome. We do this a lot internally, and it's something that I'd encourage you to take a look at and maybe try doing yourself. This is another thing to bear in mind, is that auditing is awesome, but you're not going to find things, you're not going to find everything. So having an external perspective on this stuff is incredibly valuable. It's incredibly valuable having an experienced third party look at your code and look at the possible risks that you have in your code, which is where we come onto penetration testing in a not so obvious segue. So essentially there are two types of penetration testing, white box and black box. Again, you may have come across these things before in these terms. They're known by different things. White box is open box, black box is closed box, and there are hundreds of terms. But essentially the difference is that white box is a set of people who aren't usually working on the code, coming and looking at your code and then going from the outside in. Saying, okay, I see they're using active record in a certain way, I see they're doing XHR requests in a certain way. I understand through my knowledge of penetration testing that doing that can lead to A, B, and C problems, and therefore I'm going to test for those problems. Black box being the other way around, going outside in and just looking at the behavior of your application and the way it works and trying to attack it using that same set of knowledge. Both are valuable, both have different pluses and minuses. I'm kind of black box, just because it leads to, you start to get some of that bias that you get from not seeing your own blindness when you do white box in some circumstances. But again, if you manage it properly, it's great. Also, penetration testing versus vulnerability scanning. They're two halves of the same coin, two sides of the same coin in some contexts, in that they both use the same tools and they both generally have the same endpoint, which is discovering whether your application is vulnerable to a set of common or not so common vulnerabilities. For instance, there are tools that people use like AppScan, which costs a fortune, which you probably never want to use. But the one at the bottom I'm a huge fan of that you've probably heard of before called Metasploit. Metasploit is an open source and freemium tool that hundreds and thousands of people have produced modules for that are common attacks, SQL injection, XSS, and lots of other stuff. It's a great tool that if you're starting to look at penetration testing or auditing, I'd encourage you to take a look at. There are open source modules for virtually every kind of attack you can imagine, everything I've talked about here and everything else I probably haven't. This is also something I want to mention, is essentially security regression testing in a CI environment. This is a really awesome concept that I've started to work with personally. It's essentially using Chef to build up an environment that essentially builds a Metasploit environment that in your CI environment does security regression testing. It finds all the things you failed at before and all the common things lots of applications fail at and tests your application against them all the time. And this is really, really valuable. You can get so many insights from doing this. So to make sure that you had one exploit with some XSS or stored XSS or affected XSS and test every time you deploy that it's not happening again, which is really awesome, as I'm sure you can understand. But penetration tests, as opposed to vulnerability analysis, they're fundamentally manual. They're fundamentally someone sitting there with industry expertise and using sort of unique tests. It's essentially saying, okay, I look at your application, I look at the way it works, I'm going to devise a set of tests that's going to best, in my experience, break your application in interesting and strange ways. And also yield reports. I mean, it's like, that sounds like a very simple thing to say, but reading a report from a bad penetration testing company is 500 pages of, no, this doesn't happen, no, this doesn't happen, with one page at the end, maybe say, yeah, this can happen in certain circumstances. But these specialized reports are about saying exactly what your application does and how it fails and when it fails. Yeah, and that's a great little quote at the end I love. Amateurs have tools, professionals have people, and that applies greatly. So some key things about testing and about doing penetration testing to bear in mind. The first of which is it's very easy to roll up these environments because you have to test against production replicas when you're doing penetration testing, right? Don't do it in production because people will break things and it will be unfortunate and some poor ops person will get a call at 4 a.m. that the entire application's down in very strange ways that no one knows how to replicate. Roll up another environment or do it in staging or whatever word you have for it. And you have to have accurate data. A lot of people do this with, for customer security reasons and customer data reasons, that, okay, why don't you use some strange data set that we've contrived that you can use? And that can be fine in a lot of circumstances, but in my experience, it can generally lead to issues with discoverability, with reportability and other things. And we can talk about this more afterwards in the question and answer session if you're interested. I won't go into too much detail because I'm running out a bit of time, but essentially this is the life cycle of a pen test and how it works. And generally what the stage that a good pen tester will go through when they go through this process. Again, I'm not going to go into this in too much detail just because I think I'm running out of time. Talk about internal versus external. I talked a little bit about this before. External is always really valuable, and probably when it comes to your internal team, you may not have the expertise needed to do this well and do it accurately. And the final thing I want to mention is that pen testing is unfortunately synchronous. In the way that auditing fits really nicely in with the GitHub flow, pen testing really doesn't. It's unfortunate, but it's the truth, in that you have to have a gold release with no code changes in a stable environment that can be there for a week or 10 days before it's actually validated by a pen testing company. And that isn't necessarily conducive to developing a product in a lean, agile way, which we really love. So on that final, rather depressing note, I'm going to say thank you. I've been Joe Peterson, and if you have any questions, come see me.